simpler here, and this something simpler is here, right? This is a problem about throwing a ball up and coming down again. Okay, the upward journey and the downward journey is controlled by these five equations of motion, or four, sorry, four equations of motion that you are familiar with. So it's something like the previous case. You list out all the variables and decide which formula you want to use. Which formula you want to use, right? Again, our convention is going up is positive, going down is negative, right? Okay, so you read this problem and treat it as a problem for equation of motion. The equation of motion we have seen in the last topic is this. These are the equation of motion. V equals to V naught plus AT, delta x equals to V naught t plus half AT square, V square equals to V naught square plus 2a delta x. So these are the equation of motion, and we are going to apply this equation of motion into this problem. To this problem here, the ball is thrown from a building, right? You read this question and see 2.8. Slowly, read slowly, then try to imagine what is going on.
A ball is thrown from the top of the building with an initial velocity of 20 meters per second straight upward, and an initial height of 15 meters above the ground. The ball just misses the edge of the roof on its way down as shown in the figure 2.2. Determine the time needed for the ball to reach its maximum height, the maximum height, the time needed for the ball to return to the height from which it was thrown, and the velocity of the ball at that instant. The time needed for the ball to reach the ground, and the velocity and the position of the ball at t equal 5 seconds. Neglect air drag.
Okay, the problem with this is that what they ask us is actually in sentence form. There is no symbol at all. You see the first question here. The time needed for the ball to reach its maximum height. So, I mean, time needed for the ball to reach its maximum height. They are all in words. They are not in symbol. How am I supposed to know, right? So we try to convert this sentence or phrases like this into symbol. We try to convert sentences like this into symbol. Try to imagine what is happening during this process. So if you know what is happening during this process, then you are able to change these words into symbol. Okay, maximum height, time needed for the ball to return, and so on. There is no symbol at all inside what they ask. Well, the problem is how to convert things like this into symbol. Of course, if you are looking at it for the first time, you don't know how to convert to symbol. So I have to tell you, hey, this is how we are going to convert to symbol. What does this mean? What does maximum height mean? And so on. So I have to tell you one by one, right? Okay, so you don't have to worry, don't have to worry. Okay, so the first one, a ball is thrown from the top of a building with initial velocity of 20 meter per second straight upwards at an initial height of 50 meter above the ground. Okay, the ball just misses the edge and so on. Okay, right. So the first one, how to convert this? How to convert this? Initial velocity 20 meter per second. So I'm going to convert this to V naught is positive 20. My hand is shaking. Okay, V naught is positive 20, right? Oh, why V naught? Because this is the initial velocity. That's why I call it V naught. Why positive 20? Because we agree our convention is moving upward means positive. So I write down there V naught positive 20. Now another convention is that we all agree earlier on the starting point is zero level. Okay, the starting point is zero level. So our zero level is actually 50 meters above the ground. This one you have to remember. Our zero position is 50 meters above the ground. Okay, so if you look at this line here, can you see this line here? I'm moving it. Yes. Now this line is our zero position. This line is our zero position, and this zero position is here. It is 50 meters above the ground. So these 50 meters include the height of this person until where he projects the ball upwards, right? Until where he projects the ball. So the 50 meters is the length or the height of the building, and also a part of the height of this man. Okay, so this level we call it zero. We call it the zero position. Okay, so at this position, the time is zero, the position is zero, the velocity, initial velocity is positive 20 meter per second. So that is how we convert all those numbers into symbols. We convert all those numbers into symbols. Okay, right. Then what are you supposed to find? Find the time for the ball to reach its maximum height. Now, at this maximum height position here, at this maximum height position, there's nothing that we know. There's nothing that we know about this. Only one thing we know is that at this maximum height, the final velocity is equals to zero. The final velocity is zero because when it reaches the maximum height, it will stop there instantaneously. So that is the only thing we know. So coming back to our problem, so I list out here V naught equals to positive 20. The initial position is 0 and the final velocity is 0 when you reach here. Starting T0, V0, the Y is 0 and the V naught is 20. And at this position, the V is 0, the final velocity is 0. So what you want to find is the time. What you want to find is the time. So I add one more here. We want to know what is the t equals to. What is the t equals to? This is what we want to find. So looking at this problem, we know initial velocity, final velocity, the position, and we don't know the time. Or another thing we know. What is it that we know? We know the acceleration due to gravity. The A equals to G equals to negative 9.8. So these are the things that we know, right? So what are the things that we know? Okay, we know V naught, we know V, we know A, we don't know what is T. We don't know what is T. So what is the equation relating all these quantities? V, V naught, A, and T. Which one of this
First one.
equation? Yes, the first one. the first one. So I substitute all the values that I have listed out here into the first equation. The initial velocity, is 0. The initial velocity is 20, final velocity is 0, acceleration is negative 9.8, and the time we don't know. So solving this linear equation, I have the answer 2.04 seconds. So it means that at this position, when the velocity is 0, the time is 2.04 seconds. So it is, how to say, if you are looking at it for the first time, it is quite difficult because we are going to convert all these phrases into words, into symbol. Now, any question or not for the first part? No, huh? No question. Then we move on to the second part. Now, the second part is still talking about the same thing. They are still talking about the same thing. They're still talking about the same thing here. And what is the same thing? The same thing is the maximum height. Now, earlier on, we say that at this position, the V is 0. And we have calculated the time to be 2.04. Under the same condition, that means all this, under the same condition, all these condition, same, right? At the V equals to 0, I want to know how much it has moved upwards, the distance here. So let me see first. You just wait. Oh, same. Okay. So it will all be the same here. Okay. Okay. So I paste it here. Oh, yo. Too big already, the words. Okay, I make it smaller. Okay, right. So the condition is still the same, right? The condition is still the same, except that now we want to find the maximum height. Except now, this we know is 2.04. 2.04. We now want to find what is the delta x. What is the delta x? Because we want to know the distance, the displacement. Okay. Okay, we want to know the delta x. So this is it, right? Okay. So now I take this, I put to move this down. I put this up here. We are still talking about the same problem. Throwing the ball upwards until it reaches the maximum height here. At the maximum height, we know the velocity is 0, and we have also calculated the time to be 2.04. So now what are the things that we know? The things that we know are initial velocity, final velocity, acceleration due to gravity, the time. I want to find out delta x. So which formula to use? Which formula to use? Initial velocity, no. Final velocity, no. Acceleration, we know. Time, we know. And we want to find delta x. So looking at this formula here, how many involve delta x? There are two of them. The second one and the third one. So it is up to you to decide which which one you want to use. I think both also feasible. Both also can be used. Which one you prefer to use? Oh, let's say you prefer to use the second one, right? The second one here. Delta x is v naught t plus half at squared. So this is the one that you want to use. Where? This one, sorry, I found the wrong one. Okay, so this one is what you want to use. We want to find the displacement here. So this one, just leave it there, delta x, because this is what we want to find. Initial velocity is 20. Initial velocity 20. The time from the top here, 2.04, half at squared. Half a is negative 9.8. T we have found earlier, 2.0 square. So you use your calculator, calculate all this. The answer is 20.4 meters. That means you go up 20.4 meters. Now, if you don't want to use this formula, you want to use the third one here. Can or not? Can. Because you know the final velocity is 0, initial velocity is 20, and the A is negative 9.8. So you can also use this to find out the displacement, the difference in displacement here. So both can be used. So you think about it, list how to list out all these quantities here and which formula to use, right? So these are the quantities that you have listed out, and this is the formula that you need to use. Any question?
No question.
No, because you are looking at it for the first time, right? So probably you are not so, how to say, you cannot visualize all the physical quantities lah. So after this you go through again, right? You go through again, then probably if you face another problem here, right? This is another problem, then afterwards you go and try this, all the other questions that I've given you from the book, right? Okay, third question is here. Time needed for the ball to return to the height which it was thrown and the velocity of the ball at that time. Now, what does this mean? What does this mean? Okay, now it means like this. The ball you throw up, right? You throw up, then it will come down and back to the same level. Now at the same level, but this time it is coming down. You go up, then you come back to the same level. Now at this time, right? The time needed for the ball to return to the height from which it was thrown. So that means you go up and you come down. What is the time taken for you to go up and come down? So at this position here, when it come back to this position, what is the situation like? What are the things that we know when they come back to this position? What are the physical quantities that we know when they come back to this position? Okay, so we start from here. Now, at this position, the y is 0. Okay, at this red line here, the y is 0. This one, right? This one. I put delta x there. Actually, it should be y. The y is 0. Let me change it to y. This one, you come back to the same position, the y is 0. Actually, the y is the delta x also lah. So I put there equals to y lah. The delta x is y is equals to 0. Okay. The starting velocity is what? The starting velocity is 20, positive 20. Acceleration due to gravity is 9.8. Okay, so what is the time? This is what they want to find. Which equation you are going to use? Delta x, v naught, a, and t. Which equation has all these four physical quantities? So I go back, I check here. This is the one. This one, the second one. So the second one, I quote the formula from the top there. Delta x equals to v naught t plus half at squared. The delta x is the position. The position is 0. Coming back to the same position is 0. Then the initial velocity is 20 t, right? Half at squared. Half a is negative 4.9. A is 9.8, so half a is 4.9. So negative 4.9 t squared. So this is the equation that I get. How to solve this equation? You have to factorize, right? Factorize this. There is a common factor t there. You take out the t, then you are left with 20 minus 4.9t equals to 0. Now from this quadratic equation, we know there are two values for t. First one, t equals to 0, and the second one, t equals to 4.08. Then what is the t equals to 0 mean? T equals to 0 means this one, during the starting position here. During the starting point here, the t is 0, the position is 0. The position is 0. Then the next time when the position is 0 again is 4.8. So when you go up, come down, there is another time where the position is 0. This is the one, 4.8. So there are two times when the position is 0. The first time is t equals to 0. The second time is t equals to 4.8. Okay, so this is the t equals to 4.8. Right. Never mind. So time already. So